Hello, so in this video we're going to talk through integrating trigonometric and exponential functions. Now, we're going to play quite a lot in this video on the idea of an antiderivative. So what an antiderivative says is, look, if I know a function which when I differentiate it gives me another function, and if I'm trying to integrate that other function, the function over here, then I should just be able to say, because integration is the reverse of differentiation, the original function or the answer should be equal to this. Let me try and illustrate. In the first case, I'm trying to integrate a cosine of 4x plus 5. We'll worry about the e to the power of 7x minus 5 later. Let's just look at the integral of cos of 4x plus 5. Well, look, I know my circle. I know that if I start with sine and if I differentiate it, I end up with cosine. And if I differentiate cosine, I end up at negative sine. And differentiate negative sine, I'll end up at negative cosine. And if I'm differentiating negative cosine, I'm back to sine again. Which means that if I'm trying to integrate, I should just work around the other way around the circle. Because I know that negative cosine is the derivative of negative sine, which means when I'm integrating, I'm just basically doing the reverse. And likewise, the integral of negative sine should be cosine, the integral of cosine should be sine. So in which case, I've got in this case cosine, I've got the cosine function up here. Which means that when I integrate it, I should end up at sine, because I'm just doing the reverse of differentiation. So I know that this thing should look like the sine of, well, whatever's in there. But of course, it's not just the sine of x which I've got, it's the sine of 4x plus 5. Now, just check. Remembering that integration and differentiation are reverse of each other, if I start with sine of 4x plus 5 and differentiate it, I should end up with cosine of 4x plus 5. Well, in this case, I don't, because if I differentiate sine of 4x plus 5, I end up with the cosine of 4x plus 5 times by 4, because I need to times by the derivative of my inside function. It's just chain rule. So because I don't have a 4 in multiplying this original function, it means that I need to divide by 4 in my answer. Because now if I multiply by 4, the dividing by 4 will just cancel it anyway. Okay, so hopefully that makes sense. Okay, so let's move on to the second function, which is my e to the power of 7x minus 5. Well, I know it's going to be minus. Now just remember that the derivative of e to a function is the derivative of that function multiplied by e to that function. Now in this case, I should end up with e to the power of 7x minus 5, that's e to the power of my function, but I don't end up with a 7 at the front, okay? So in which case, because I don't have a 7 in front of my original function, I need to divide by 7 to cancel it, okay? Because of course, if I differentiate that thing, now I'm back to e to the power of 7x minus 5, okay? Because the derivative of a 7th, e to the 7x minus 5, is a 7th times 7 e to the power of 7x minus 5. So the 7th and the times 7 cancel, okay? Now, of course, I must remember to also add my constant of integration. So that there would be the integral of this thing here. So just think about it as the fact of, I know when I differentiate something, I get something which is close to both of these things, then just need to think about the factors which they're off by, okay? And just make sure you multiply that. Okay, fine. Okay, so next question then, we've got the integral of sec squared of 4x with respect to x. Well, just remember, go into the back of your minds and just think, do I know a function which when I differentiate it, gives me sec squared? Yes, I do. I did that in one of the videos. So I know that the derivative of tan of x, so tan of something x, so tan of x, should give me my sec squared of x, okay? However, that's not what I've got here, okay? So that's not quite what I've got here. I've not got sec squared of x, I've got sec squared of 4x, okay? So if I put a 4 in front of the tan of 4x, then sure, I get my sec squared of 4x. However, I also get 4 sec squared of 4x, which means that my final answer is not just going to be tan of 4x, it's going to be a quarter of tan of 4x, because that quarter will cancel with the 4 out here just to leave me with the sec squared of 4x. So in other words, that's a long way of saying the answer is saying this is just a quarter of the tan of 4x plus c, of course. Okay, so that would be the answer there. Okay? Okay, so this one, slightly different because we've got limits, but it's still the same idea. So just remember, don't worry about the 6. I'm actually going to pull the 6 out the front so I don't get confused by it. So I've got the the integral between 0 and pi by 6. That's basically saying find me the area between the x-axis and this curve, 6, 3 cos of 3x, between 0 and pi by 6. So if I pull the 6 out, this just basically becomes cos of 3x with respect to x. Well, okay, the integral of a cos function, just thinking about my circle, should be the sine function, so I'll have sine of 3x. I must remember to divide by that the derivative of the 3x, which in this case is 3, and of course I'm multiplying still by the 6, because I've still got that hanging around at the end, okay? So 6 times a third, that just gives me 2. Okay, now, of course, I've still got plus c, and I need to put in my limits, so between 0 and pi by 6. So same idea as before. All I need to do, first of all, is put in my pi by 6. So I end up with 2 sine of 3 lots of pi by 6. And then I need to take away, so plus c, but I know they're going to cancel anyway. Then I need to take away putting in 0 into this function. So I get 2 sine of 3 times 0, then plus c, which is just cancelled anyway. Okay, so that should be equal to that. Okay, so the plus c's are cancelled, which hence the reason I'm not writing them in. So this should be equal to 2 sine, well, 3 times pi by 6, that's just going to be pi by 2, minus 2 sine of 0, okay, because 3 times 0 is just 0. Okay, so sine of pi by 2, thinking about my curve, that's the same as sine of 90, which is 1. So I get 2 times 1, which is 2, minus, well, sine of 0, that's just 0, so 2 times 0, that's 0. So therefore, the final answer should just be equal to 2. So in other words, the area between the x-axis and my 6 cos of 3x curve between 0 and pi by 6 is giving me an area of 2.